Well, thanks for having me. This will be fun. Regarding house interior, I just want to go over real quick what we're supposed to inspect, the minimum standards of practice. So obviously we look at walls, ceilings, and floors. And then of course we've got item B, steps, stairways, and railings. And that's what we're going to talk about tonight. Of course, there's a lot of other stuff, but basically I want to focus for maybe, about the next hour, maybe a little bit less. We're going to talk about stairways, landings, and rails. So a lot of stuff there, a lot of things to look at with stairways. And I think a lot of inspectors, well, and myself included, when I first started, we just kind of go up and down the stairs. And if I feel like I'm going to trip, well, there's got to be something wrong. So, then of course I started looking at the spacing of the balusters and so on. But there's a lot to look at. And you know what? A lot of people fall on stairs. So that's something else to think of. And I've worked on quite a few claims now where people have fallen both up and down stairs, and it can be pretty serious. People can get hurt, so it's something that we need to look at pretty close. So then, of course, we have the exceptions, things that we are not required to inspect. But what are we looking for? Well, basically things that aren't functioning properly, are significantly deficient, which could be stairways. And then we have this number 3 item, which always kind of scares me, where we have to look for things that are unsafe. So, we almost have to kind of predict, well, what could happen here? What could happen on these stairs? How could people fall? Well, we want to look close for conformity with minimum standards on stairways. And it's kind of tough because many of us do really old houses. I grew up in a real old house in Connecticut, built in, around 1850, and it had some really steep stairs, and they certainly were not had rise and run like you would see required in modern homes. Then, of course, near end of service life, stairways can be at the end of their service life, especially bulkhead stairs in basements. You want to look at those close because many times they're pretty well rotted out, and you find out that they're defective when the plumber stands on it with a water heater on a hand truck. So look closely at those. Then, of course, we have to describe required systems or components. All right, so let's talk about interior stairs and landings. Now, I know I've specified this as interior stairs and landings, and that's more to limit this discussion because we only have, maybe a little bit less than an hour. But frankly, the building codes, the IBC and the IRC, do not specify or differentiate between interior and exterior stairways. It doesn't matter where they are. If it's a stairway, it should comply. And I see a lot of stairs on grade, in the backyard, maybe going down to a pool or a spa. And many times they don't have handrails, they have improper rise and run. And you know what? I don't care where it is. I'm going to recommend that it be upgraded for safety purposes and that there be a handrail installed and so on. I know some people say, oh my God, really? Well, yeah, it's a stairway. And I've had some people, I had a builder one time say to me, complain about the report, said, well, they're exterior stairs. The code doesn't have any say in how you build exterior stairs. I said, well, the code book doesn't specify interior or exterior. It's stairways. That's it. So it should comply. And I'm not forcing people to fix anything. Many times I'll recommend something for optimal safety in my report. I don't care if you do it. I'm telling you the way that it should be. And if you choose to not fix it, that's your problem. So I told you that it's unsafe and should be fixed. And I gave you what the modern standard is and recommend that it be corrected if it's something newer or upgraded if it's something older. Okay, so let's talk about stairs and landings. And basically stairs, stairways, staircases, whatever you want to call it, is just a means to get from one vertical level to another. So you've got 2 levels, 2-story houses, so you have to go vertical to get up there. And a stairway is a way to do it. You could use a ladder, but that's not very safe. You could certainly use a vertical transportation like an elevator. That would work, but they're expensive. So landings are the flat area at the top and the bottom of the stairs. And sometimes in between. It depends upon how many steps and what the vertical rise is, and we'll get into that here in a couple of bullets. So we want to have a landing that's at least 36 inches deep in the direction of travel. It also should be as wide as the stairs. And most stairways are going to be 3 feet wide. Some are wider, it just depends, but the minimum is going to be 3 feet. Now, some older homes might be 30 inches. That was changed, I think, in maybe the early 80s. You could do or build a 30-inch wide stairway, which we probably see in many older homes. And then there shouldn't be any more than 147 vertical inches or vertical rise between landings. Once you hit that little over 12 feet, once you hit that 147 inches, you need to put in a landing so that there's a stop area, and then you can go on to the next stairway. So when you have an intermediate landing, basically what you have are 2 stairways. And then stair risers, those are the vertical portion of the stairway that creates the lift. And it's the distance between the treads, or the horizontal portion that we step on, that's the tread. So the rise is the vertical piece in between. And we'll get to what all those do here in just a second. So landings should be 36 inches wide and 36 inches deep. Pretty much that's going to be the standard. Now, there are some exceptions. You can have some angles in them, which we'll look at a picture of here in just a couple of minutes. What really matters is the width at the travel location, or the area of travel. And we'll see what that is here in just a second. So the walk line, and the walk line is considered to be the area within 12 inches from the corner. So that walk line should always be at least 36 inches. So it's okay to have a curved landing like this, but it can't interfere with this walk line area. You can see from this plan view schematic where that's got to be the 36 inches width. So the walk line should not be interfered with. So it's okay to have a radius over here. That's all right. But as long as you have 36 inches wide here, which is what we're looking for on this stairway. And I'll show you what that looks like in a couple of minutes, where you might see that in the field. And remember that all our measurements are from the nosing leading edge. A lot of people measure treads incorrectly. The depth of a tread should be measured from the vertical distance from the nose. So we'll look at that in just a second here. All right, so a flight of stairs, if you have a landing, it's going to be the stairs between the 2 landings. So you may have 2 flights of stairs if there's an intermediate landing. And then the treads, or the steps, are the horizontal part that we stand on. And then winders are going to be narrower at one end than the other. And usually they're used to change direction of the stairway. And there's some minimum depths on those we'll look at in a second. Now, regarding measuring the tread depth, in the definition in the IBC, the tread depth is measured horizontally, okay, the depth where you put your foot, basically, between the vertical planes of the foremost projection of the adjacent treads. So that means from the end of the nosing, vertically down, and at a right angle to the tread's leading edge. So the depth of the tread, if you've got a 1-inch nosing, that tread needs to be basically 11 inches if you're going to measure it all the way to the piece of wood on the back at the riser. Because remember, it should be measured from the nosing. So we'll show you some pictures of this in just a second. Okay. So here we have multiple stairways. We have an intermediate landing, and you can see that we have finished riser heights, should be 7 3/4 inches maximum. Does anybody know what the minimum riser height is? I know you can't talk because everybody's muted. It's 4 inches is the minimum riser height. But we're going to see pretty much 7 3/4. In some older homes, we might see 8. I remember seeing 9 in some older homes, but 7 3/4 is the maximum finished riser height. And most of the time where we see them screwed up is going to be at the top one or the first one, because people change floor coverings, and that's what screws up the risers. So other times they're just built bad and they're all different, but usually what I see in the field is we've got a problem at the first riser or at the top riser, or both of them, because floor coverings were changed. The finish level or finished height of the floor is now different, which caused a problem there. So the depth of the tread should be a minimum of 10 inches. Now, if there's no nosing, which looks like this illustration is showing here, I don't see a nosing, the tread depth should be at least 11 inches deep. That's when there's no nosing. Okay, no nosing on the tread, it should be 11 inches. So with nosing, it can go 10 inches. And the difference between the treads and the risers in a flight, the maximum difference, is 3/8 of an inch. That's pretty tight. So, and usually I can feel that. When I'm walking up the stairs, I can usually feel it. So when you pick your feet up to go up the risers, usually if there's a distance, most of us only pick our foot up about 1/4 of an inch above what the actual height is. It's just the way that we walk. And we walk upstairs, we pick our foot up about 1/4 inch more than the actual height, which is kind of cool how the brain just does that. So when there's a difference, you could pretty much, you're going to feel it. So when I can feel it, obviously I know something's wrong, but many times I have to take a measure stick and make sure that I'm correct. So anything that's more than 3/8 of an inch, or actually 3/8 of an inch or more, out of whack is definitely something that's reportable. So, and it doesn't sound like it's anything that's major, but remember that a lot of people fall and get hurt on stairs. So we need to be careful how we're reporting this, because remember that we have to report things that might be unsafe. That's part of the standards of practice for us as home inspectors and ASHI members, is to report something that could be unsafe. So it's important to document conditions and recommend correction of any conditions that we might see in a stairway. So I'm kind of a stickler when it comes to stairs. Okay, so winder treads, and these get screwed up all the time. And this stairway looks great. However, if you look at the inside corner here, a couple of things. The smallest dimension, which is over here where my cursor is, that smallest dimension should be at least 6 inches. So no less than 6 inches of tread depth here. And it looks like we've got maybe 3 inches, maybe 2.5, 3 inches or so. And we should make, by the time you get to be 12 inches out from the inside here, we need to make our minimum tread depth of 10 inches, which I don't think we have it here. So, it looks like a lot of work went into building these winders. Unfortunately, they're incorrect, and they're going to be a trip hazard. So this area here, the inside is where most people walk. So this is considered to be a path of travel, which is why anytime you build winders like this, they need to make that tread depth of 10 inches by the time you get to be 12 inches out. So it looks like maybe this one has it, but these two are definitely not making it. This one here, maybe, but it looks like it's close. So a lot of times these look pretty good. And the rise is good. It's all within 3/8, but be looking here. Look at these areas. And you can get your code checkbook and take it with you, because there's pictures right here. You see here? There's all the pictures in the code checkbook. So you don't have to remember all this stuff. You can just, if you think it's weird, just go out in your car and get your book and take a look at it. So, there's a lot of numbers to remember, and we don't have to do that. Okay, so the risers are the vertical part of the stairs, and they can be open or closed. Now, we all know that when they're open, there shouldn't be any opening more than 4 inches when you get to be 30 inches or more above the floor below. So open risers, if you see them on older houses where they're open, they could be sometimes 6, 7 inches open. Those are a potential hazard, especially to children and pets. So we recommend that they be closed. And then the nosing is the projection of a tread beyond the closed riser. Typically, you don't have a nosing when they're open riser treads. And then the stringers, those are the components that support the treads. So I'm sure everybody on this call knows what they are, but I just want to make sure. We'll just go through them quick. Okay, so some different parts of stairways. We've got newel posts. You can see here we've got one up top, a couple of them up top, one down at the bottom. Typical handrail, and then we have the intermediate balusters. Here's a stringer. Then you have, would be a skirt board to cover that triangular type area at the end of the tread. And we've got a lower and an upper landing here. And then we've got nosing on the tread. You can see they're showing one here on the bottom. And we've got the tread is the horizontal portion where you put your foot. And then the riser is the part that gets you the vertical gain. So, and that should be maximum 7 3/4 of an inch. So typical components of a stairway. Now, a lot of things have changed over time. So, especially headroom in stairs. Gosh, it used to be 6'4", then it went to 6'6". Now it's 6'8". Back when we used the uniform building code, your treads could be 9 inches with 8-inch rise. Of course, back in the pre about 1920 or so, or 1915, there wasn't any code, and people just built whatever. So, and then we used to be able to have 30-inch wide stairways. Imagine carrying furniture up, something like that. So a lot of things change over time. And of course, failure to comply with modern standards isn't a defect. However, I still note what the modern standard is, and I recommend upgrading because, people fall on stairs. And you know what? If I don't say anything about it being an old stairway and not compliant with modern standards, I'm probably going to have a bit of a problem. So I always recommend upgrading to modern, safer standards. And I'm sure people, I doubt any client has ever fixed it, but I told them. So that's the main thing, is I tell them what's up in the report. So maximum riser height, 7 3/4. Remember, your minimum is 4. And taller risers, you're going to find a lot in older homes. And we want to make sure that there's no openings larger than 4 inches in open risers. So if that happens a lot, where anything a kid could fall through. And then tread depth should be at least 10 inches. And we need to measure that from the adjacent tread leading edge, which is the nosing. And narrow treads can be a hazard because you don't get a full area to plant your foot on. So note it. And also the maximum slope of a tread from level is 2%, so 1/4 inch per foot. And usually you'll see that on outdoor treads, maybe on the stoop going up to the front door. You might see that the treads are sloped, which would be a good idea because you want them to slope to drain, excuse me, so you don't have any ponding water on those treads. So maximum slope for treads is 2%. And also, like I said before, when we used the uniform building code, I remember we had uniform building code, we had standard building code, and I think in New England we had national building code. So we had these 3 different building codes that allowed us to have riser heights of 8 inches and tread depths of 9 inches. And that's up to pretty recent. 1997 is not that long ago. So at least it isn't to me. And then older homes may have those 30-inch wide stairways. And then I just recommend that they be changed or consider upgrading. This is kind of the wording I use. Consider upgrading for optimal safety, which I haven't had anybody call me and say, we don't want optimal safety. Why are you saying that in your report? I've never had a call back about that. So, I don't have any problem with recommending that. Okay. And then winders, we kind of touched on this before. You got to make at least 10 inches deep in the tread, at least 12 inches into the stairway. And then that minimum 6 inches depth anywhere. So at the small end has to be minimum 6 inches of tread, not 3, not 4. It needs to be 6 inches. And the 3/8 differential, we talked about that. And then nosings. I see a lot of nosings that are totally screwed up. So it should be 3/4 of an inch to 1 1/4 inches. That's it in a flight of stairs. So that's what the nosing can be. I looked at one recently, the nosing was 2 1/4 inches. And the treads effectively, because of that, were about, I think 9 and 9.5 inches or so. So it really screwed up the stairs. And then the difference in nosing depth How many of you have ever measured this? The difference in nosing depth should not be greater than 3/8 of an inch between the top and bottom landings, meaning in a stairway. So that 3/8 applies also to the nosings. And you'd be surprised if you measure the nosing, the difference that you can find sometimes, especially if people have changed the floor covering. One of the real culprits is when they add laminate flooring, the snap together stuff, to the stair treads. And a lot of times at the nosing, there's some kind of piece of wood that's used there, a transition or whatever the heck they call it. And they're awful because they sit up a little bit higher than the floor and they move, and it's easy to catch your foot on. Those are hazardous. And I've seen those quite a bit where there's laminate flooring installed at the stair treads, and that with whatever they cover the nosing with there is it's like an L type piece, but it's got a bit of a rise to it, and very unusual because it changes the profile and it causes people to trip. So be careful when you see those. Okay, so winder treads, let's just make sure we've got this clarified. At the small end here, minimum 6 inches, and you need to make tread depth of 10 by the time you get 12 inches in, right here. So that's it. And I think there's pictures. Yeah, there's pictures in the code check book here too. So make sure you have that. And if you need to refresh your memory, when sometimes the stairway list looks kind of odd and you have to refresh your memory. So go back out in the inspection wagon and take a look at your code check book or whatever reference you use. And because you don't have to try and remember all this stuff, especially stairways. It's a heck of a lot of numbers to remember. Okay, so headroom, modern requirement, 6'8". Now, it used to be 6'6", then it was 6'4" before that. I see a lot of stairways, especially those ones on the capes where you're going up to the attic, that finished room that's upstairs, and you have to bend your head like this to get up there. Those are obviously it's less than 6 feet. So report that. It's incorrect. And what are you gonna do? How are you gonna fix it? You're gonna poke a hole, do a dormer in the roof to give you enough headroom on the stairway. So I guess you could. I mean, that's one way to get around it and fix it. So I just note the deficiency. Usually it's pretty obvious, but even though it's obvious, I'm still gonna note it and recommend that people use caution when using the stairway. I mean, what else? Recommend correction for optimal safety. And what else you can do? Okay, headroom for spiral stairs, a little bit different. 78 inches, so 6'6" for spiral stairs. And we'll look at some examples of those in just a minute. And then, of course, minimum stairway width is 36 inches, and this is above the handrail, by the way. I think it's 27 below, but I could be wrong. I have to check that. Stairway lighting is important. I'm working currently on a claim where somebody fell on some stairways or on a stair because of, they're blaming lack of lighting, and actually it's the truth. There wasn't any lighting, or it wasn't appropriate. So there should be a switch at the top and bottom landings if there's 6 or more risers. So, and it's really hard to tell if the lighting is correct when we're doing an inspection. Usually it's during the day. At least the ones I do, it's usually during the day. So the lighting should illuminate all the landings and all the treads. You should be able to see. So I just look up and make sure there's a light above the stairs or close by that's going to illuminate the treads. Okay, so here's our minimum distances. The width of the stairway, 36 inches above the handrail. It's 27 inches between handrails if there's 2 of them, and then 31.5 inches between the handrail and a wall. So these are our distances. So a lot of numbers to remember. So that's why it's good to have kind of a cheat sheet or code check or some kind of book you can use to take a look at it, because it is quite a few numbers. Okay, stair stringers, when you can see them, because a lot of times we can't see them because they're covered with drywall, which is what they should be covered with if there's storage space under stairways. It needs to be covered with drywall. So the stringers, the throat depth should be at least 5 inches or so, and that's a recommended number. It's not a required number. if I see anything that's 3 or 4 inches or less, that's definitely reportable because that's a lot of the meat gone from the material. And then dimensional lumber stringers should be secured. It needs to be supported at the top and the bottom. It needs to be something holding it in place. So, there's not really any prescriptive rules, but the plumb cut should be bearing fully, not a half an inch. I'll show you a picture of that. And the seat cut should be bearing, and it should be bearing on the long part, which is the heel, not the little toe part. So the deck stairway information actually could tell you a lot about these. It's pretty much the same. So 5 inches here should be minimum. And remember, here's a good diagram showing us how to measure your tread depth. So we should be measuring from a vertical line from the end of this, the nosing down. That's our tread depth here. See right here? That should be our 10-inch minimum tread depth. So a lot of times they're wrong. A lot of times they're 10 inches full here, but the nosing is 1.5 inches. So that would be incorrect. That's not a proper way to measure your tread. Now this one we can actually see the plumb cut at the top of the stairs, and you can see it's just kind of hanging there. There's a couple of shims installed, and I can't tell what's holding this up because there's material in the way, but it doesn't look good to me. So I'm going to recommend additional support, maybe some hangers, something here to hold this stairway. This is the top of the stairway, so it doesn't look like there's much holding it in place. I think stairways in newer homes are usually much better because typically carpenters on site, the framers, don't build stairways anymore. They order them from a stair company. That's all they do is build stairs, and they're pretty good at it. So most of the ones we see that are built by these specialty companies, they come out and measure and they build them and then drop them at the site. Those are usually pretty good, but they can screw them up too by not supporting them properly. Okay, so spiral stairs. These are interesting. I typically see them maybe for a mezzanine, or I've seen them used to access a deck. So spiral stairs are, kind of the ones that are not a whole lot of room and feel kind of dangerous going up and down. And they have their own rules. So riser height, 9.5 inches is maximum. That's quite a tall riser. Tread depth, minimum 6 3/4 inches at the walk line. That's 12 inches from the small end. So really totally different. And then the width, at least 26 inches at and below the handrail. So these things are just like their own total animal. And they can get screwed up too. And usually they're okay when you buy the ones that are custom made by stair companies. A lot of times they're made out of ornamental iron. But I see people try to site build these things, and usually they'll screw them up. So here's usually what we see in the field. This is spiral stairway going up to a deck. And this one's pretty good shape, although we have open risers. So this is an older one. We have open risers with that opening was probably 8 inches. So I recommended that be corrected for optimal safety. Probably wasn't required when it was built. It's been there for a number of years, but the open risers could be a hazard. Now this is a claim I worked on some years ago, 2019, where somebody fell. And this is a spiral stairway that was site built. And remember that we're supposed to have 6 3/4 inches at the walk line at 12 inches from the inside corner. And we're at about 5.5 or so here, maybe a little bit more. We're definitely shy. We're a good inch shy of 6 3/4. And somebody fell down these stairs, and eventually it got settled. Somebody got paid off. And I was one of the experts for maybe insurance company or something. I don't remember. But I went and measured it, and I told them, I said, it's wrong. So, what else are you going to tell them? You got to tell them the truth. So it was incorrectly built. All right. So we're going to see quite a few stairs with risers that are taller than current standard. And it could be, and if it's an older home, that the standards were different back then. Now, if it's something newer, it could have been built wrong. But regardless, I'm pretty much going to report it. If it's an older house, I'll say that the riser height is more than what we would see in modern homes and consider upgrading for optimal safety. I know, I can hear people out there groaning about that. But if that's what I do, just to make sure, give them the option. You could upgrade it, which is basically rebuild the stairs. They're not going to do it, but I told you that's the way to fix it. So I told you, tread depth smaller. So we used to have 9-inch treads with the UBC, and I think the standard building code too. So 9-inch was pretty common, and now it's 10 inches, and it's measured from the nosing. So usually it's because they're older stairs, or it could be if they're newer, later than 1997, which is when that code changed. Well, then it could be something that it was improperly built. So we can I recommend correction regardless, or consider upgrading. So it's up to you as the inspector. But remember that it's stairways, people fall. So we need to be. I'm a kind of a stickler on stairs, and if I see anything out of whack, I'm going to start looking pretty closely. I also take reference photos, and I'll take out my tape measure, and I'll be measuring the tread depth, the rise, the height of the handrail, guards if there's any, the difference between the balusters and so on, and just keep that for reference in my report. And here it is. We're looking at, now this is a stairway where, look at that nosing. That nosing is hanging over about 2.5 inches or so, where 1.25 inches is the maximum overhang for a nosing. Remember, 3/4 inch to 1.25 inches. So this tread, if you measure from the nosing edge, you've only got about an 8-inch tread. So it's incorrect. The tread should be at least 10 inches. So the way to fix it is to reduce the nosing. The nosing is actually the problem. The nosing is a defect because it's too long. This one, actually, I think it might have been 2 3/4. It was way different than what it should have been. So this is something, and you can see that we documented that it was incorrect and recommend correction. So are they going to do anything? Probably not, but we still want to tell them in the report. Now here's a winder, and you can see that we've got this small end here, should be what? 6 inches minimum. And this one is about 4. If we shove the end of the tape all the way into the carpet to get an accurate measurement, we got about 4 inches here. Of course, we just about a point over here. So we're being nice, and we definitely don't have 6 inches minimum at the end. Now this one, nosings, that's important. The nosing should comply with standard. It's something that you can drag your foot on. It could make you trip up if the nosings are too long. If something has covered them, like I was talking about before, that laminate flooring stuff where they put that cover over the nosing, that transition piece, which tends to be loose, and it's a different profile and height. And I find that it's pretty easy to catch my foot on that. Okay, so this nosing here, remember, it could be 3/4 inch to 1.25 inches. So this one is almost 2 inches. That's quite a bit more than 1.25 inches. So that's too much. You can see it here overhanging. That's quite a bit. So when you measure your tread, you have to put a vertical line here and measure your tread from about here to the end of the nosing over here. So that's your tread depth. And on this one, it's probably only going to be about 9 inches, maybe less, maybe 8 something. So, and that's a heck of a nosing. Somebody's going to drag their foot on that and probably fall going up or down the stairs. It doesn't give you a lot of room to put your foot down onto the tread below as you're descending the stairs. So that's hazardous. There's a reason why we have these minimum and maximum measurements for nosing, because they've done testing, and we know how people, you get into a residence as you go up the stairs, and people fall when the measurements are different from what we're seeing here. So that's why it should be compliant. So, we don't want to get blamed for people falling down the stairs. So if it's different than current standard, I'm going to note it because it's a potential trip hazard, and I'm going to recommend correction. So, and we see a lot of stairs that are poorly built, and this includes, and you guys are going to see a lot of these, basement stairs. They're freaking awful. So, and I've gone up and down a heck of a lot of them in older homes. Basement stairs, bulkhead stairs. People think that different rules apply. Bulkhead stairs, gosh, I don't recall ever seeing them with a handrail. Going out the Bilko doors, there's no handrail, and there should be a handrail there. That's a stairway. The code doesn't differentiate because it's in the basement. So, I don't care where the stairway is. It should comply with these rules. Okay, uneven treads and risers. You can see I don't even need a tape measure. Look at the height of this one. Or excuse me, that's the tread. We're looking down the stairs, I believe. Or maybe we're looking up on this one. But anyway, it's definitely uneven. So you can see the difference here and here. And it looks like way different from that one. So anything more, 3/8 of an inch or more is definitely a problem. This is a apartment that I inspected, and we had 6 and about a quarter here, and then 7 and almost a half here. Now, what happened was, this was the first one. This left photograph, what they did was change the floor covering. This is the first riser. Of course, that's where the defect usually is going to be. And what happened was they changed the floor covering, and they changed it in every single apartment. There's like 60 of them, and they're all wrong. So, and they're probably never going to fix it. And the difference is a good inch in this first riser to the other one. So I didn't even need the tape measure to figure it out. Obviously, you can feel it. I could see it walking in the front door, the difference. So that's a trip hazard. And now they've created it in every single apartment in the whole project. So, unfortunately, it should be fixed. I'm going to recommend it. They're not going to do anything, but I'm going to tell them about it. Here's another one. Got the same thing. We've got a 5.5 inch riser. And then over here, we've got about an 8 5/8 inch riser. That's a big difference. And that's all in the same stairway. So that's a significant difference. And that's going to be a problem. Somebody's going to fall. So that's definitely reportable. And that's unsafe. That should be reported by us as being unsafe because it's true. All right. Headroom, if it's less than 6'8", I'm certainly gonna say something about it. Although if it's like 6'6", I'll just say it's less than what modern standards are. Caution in this area. That's about it. I probably won't recommend correction. And this is how you measure it. So it's a line, imaginary line that's kind of tangent to the nosing, or just take your tape measure and measure from the zoning or the nosing up to the ceiling. And usually where it's going to be screwed up is going to be right here or at the top of the stairs. Now, if you have to move your head to go up or down the stairs, obviously it's way lower than it should be. I can't remember if the ceiling height ever being less than 6'4". So that's definitely way low if you have to move your head. And a lot of times that's at the basement stairs too. We have the sign there that says, or it's a picture of a duck. It's kind of funny, but still, you shouldn't have to hit your head going down in the basement stairs. Okay, so width or landing depth less than current standard. Once again, I'm going to recommend that be corrected. Now, there's a different standard if it was a 30-inch wide stairway. If you're looking at a home that's 50 years old, where it was a 30-inch stairway, obviously that doesn't have to be 36 inches. So, but I would just comment that the stairway appears to have been constructed under older standards that allowed, the 30-inch width, and it could be problematic with bringing furniture up and down the stairs and so on, because it's pretty small. If you haven't walked up and down a 30-inch stairway lately, that's a big difference from a 3-foot. Okay, So curved or angled stair or landings, which we talked about a little bit earlier. You can see this one is kind of a neo-angle type of a landing. So this one's an asymmetrical landing, and it could be okay, assuming that this is the walk line here, which I would think it is. And we need to get 12 inches, okay? Has to be 36 inches deep. Now, if the handrail was over here on the right side, that would be considered the walk line, and it would not be okay because you don't have 36 inches of depth for that 12 inches. Everybody see it? So here we've got full depth, over here we don't. So as long as the handrail is over here, that's the walk line, and that would be okay. Here's another one. Now this would not be okay. Here's the walk line. This is the handrail to the left. And you can see here that that's definitely less than 36 inches. You know, it's going to be awful difficult getting stuff up and down these stairs too, the way that they made this, because you've got this angle, and that's not going to be 36 inches there. I think it was significantly less. I think this is 36 right here to the apex of this joint, but it wasn't here. So, and that's a mistake, 35. That should be 36. I'm sure you guys know that. All right. Now, here's an interesting house. So, a couple things going on here. They have the stairway is blocked, this landing. So, we've got two stairways and an intermediate landing. And this ladder that goes up to this library atrium thing or mezzanine thing blocks the landing. And I think this handrail too was too low. Should be 34 to 38 inches in height from the treads or the floor. But this thing blocks the landing. So I recommended that it be removed. Then also we've got this condition now where this ladder is the only access to this mezzanine area, and the ladder is unsafe. It's not a stairway. So, you know, I just commented that the ladder, they tried to make it kind of like a stairway because it's got treads, but that's a ladder. And look at the height of the risers, or the rungs, I guess we should call it. It's a ladder. But, you know, that could be unsafe too. And there's no handrail. There's no place to hold on to when you're crawling up this thing. So I just said there was no real safe access to the mezzanine library area. And I didn't even recommend a fix. We're not required to do that. So I just left it. You know, it's not safe. Okay. How about tread deflection or movement? You know what? If you feel things moving underfoot when you're going up and down the stairs, something's wrong. And then illumination, improper switch location, that's a problem. So make sure that there should be, if there's 6 or more risers, there should be a switch at both levels. So it should be 3-way switch. And there should be enough lighting so that you could see the stairs, the landings, and everything from both positions, up or down. So this one was kind of odd. And I know the camera's a little bit tilted, sorry. But we've got right up here, we have a light fixture. And there's another one up here. Now the switch that turns on what's supposed to be the stairway lighting only turned on this light up here at the second floor hallway. It did not turn this other light on. This light above the door was turned on by a different switch. So, and you weren't able to operate 3-way. You couldn't turn this one off from upstairs. So kind of odd. You know, if you got a light right above the door, that's part of the stairway illumination. So I just said it was inadequate lighting and inappropriate or improper switching, because you need to be able to control all the stairway light. I don't care if you can have 5 or 10. I don't care how many lights you have, but it needs to be controlled by a 3-way switch accessible from the top of the stairway and also the bottom of the stairway. So it was incorrect. So you might want to spend a little time looking at this, because every once in a while it's kind of screwy. Okay, damaged floor covering on treads. Obviously that's a problem. Anything that moves around. Squeaky stairs. A lot of them squeak. That's your alarm system. But it depends if you want to call it. I call out squeaky floors, and most of the time it's normal. I just say, normal squeaks were encountered during the inspection. All right, handrails and guards. So you need to have a handrail on any stairway with 4 or more risers. There should be a handrail. And you only need one, only has to be on one side. And it needs to be 34 to 38 inches above the tread leading edge or the floor. So, and it must be continuous over the entire flight of stairs from the top riser to above the last tread. So the lower riser. And it needs to terminate in a return to the wall at a newel post or a volute. And I'll show you what that looks like in just a minute. And then, of course, there's specific sizing and shapes. And they need to be, main thing is it needs to be graspable. You need to be able to get your hand around it and hold on if you feel like you're going to fall, or if you're unstable. And, heck, I could be unstable if I'm quite tired going up the stairs, and it's nice to have something to hold on to. And then the clearance to the wall, this is blown quite a bit. So the space where you put your fingers between the end of the handrail and the wall needs to be minimum 1.5 inches. And if you're rubbing your knuckles on the wall or something, then that's wrong. There's not enough room there. So this is a return to the wall. Here's a circular handrail. Okay, dimensions should be 1.25 inches to 2 inches. You can see here square. And then we have the handrail with finger access on both sides. So it needs to, that's a key thing with these handrails is finger access on both sides. And then here's your dimensions. So you don't have to memorize dimensions. I would say if you can't get your hand around it and grab it, it's probably wrong. And then you might want to go and look at your book. So here's a termination volute. And it looks like that this handrail on the other side doesn't return to the wall. Okay, and then the open sides of stairways. You want to have anything that's more than 30 inches above the surface below needs to have a guard. So, and many times the handrail will act as the guard so that people don't fall off the edge of the stairs. So that works. It must be 36 inches, unless it's a handrail. It could be 34 to 38, but guards are typically installed like at the upper, if you've got an open hallway kind of a thing, walkway, minimum 36 inches above the adjacent walking surface, unless you live in California. People here are taller, I guess, or more top heavy, and you need to have minimum 42-inch height, and it must resist a 200-pound concentrated load. I don't recommend that you shove against it with 200 pounds of force because you might fall over. I kind of give them a little bit of a shake with my hand and make sure it's solid, and that works for me. The infill components are supposed to resist 50-pound load. I pretty much don't test them unless it looks, like it's weird, but you don't want to break it either. People will blame you for that. If there's any glazing in the guard, it also must be safety glazing. I'm not going to be testing that for the 50-pound load because it'll probably break. And then the guard infill, like balusters, should not allow the passage of a 4-inch sphere. So basically they need to be just a skosh less than 4 inches apart. And we'll look at a couple of those. And then we have stair guards are different. They must not allow passage of a 4 3/8 inch sphere. That changed not too long ago because it gives you more uniform spacing when you're installing the balusters. So that 4 3/8 is allows for just a better design and it looks better. So here's a different schematic. You can see we have number 5 is that 4 3/8 inch, and this triangular space here between the bottom of the guard, which is a handrail, and the stair tread, that can be maximum 6 inches gap there. And then of course up here where it becomes a guard, that's 4 inches. So only in the stairway is it allowed to be 4 3/8 inch sphere. So a bunch of information here. Okay, while we're on this subject, we put in a slide here about safety glass because windows near stairways can be a problem as well. You could poke your hand through it or your arm through it or your body through it while you're trying to grab a handrail, or maybe you're falling down the stairs. So it all depends upon distance from the tread to the window. So anything within 36 inches of the nosing, this line drawn tangent to the nosing, should be safety glass. Anything within 36 inches of the intermediate landing, safety glass. Now, if it's within 5 feet and within 36 inches of the floor at the lower landing here, needs to be safety glass. More than 5 feet away, doesn't have to be safety. So, and the one up here at the top could be any height, doesn't require safety glass. So safety glass at the intermediate landing, if it's close to the treads, or if it's within 5 feet of the bottom landing, because that's where you're going to end up when you're falling down the stairs. That's the reason why. Okay, so we're going to see a lot of handrails that are incorrect or missing, like this one here. And then we also have a problem with this winder, and that should be minimum 6 inches at the small end here. So that's incorrect. No handrail at the upper riser. This one here, that's a 2x6 installed on the wall, but it's not plowed out on both sides to give you some grippable surface. So a 2x4, 2x6, and especially on decks is where I see them, not a proper handrail. So it doesn't work. It's not considered to be grippable. Here we have no handrail. And if you look closely down here at the bottom with both of these photos, that landing is not 36 inches deep. It goes immediately to a door to the exterior. These were upper apartments. Same on this one here. That looks to be less than 36 inches. So incorrect. They're not going to fix it, obviously, but I'm still going to note it as being wrong. So no handrails and also improper depth on that landing. So lots of defects with stairways. Here we have rather steep stairway, both of these, and the handrail does not extend to the end of the bottom tread. You can see here, this one kind of twists around the corner just a little bit, but you can still make it work. Same over here. So we're missing 1, 2, 3, like 4 or 5 of the treads don't have a handrail. So definitely incorrect. Here's another one. Handrail not continuous, should be all the way down. Plus we have issues with the winders. Not 6 inches minimum at the end, not 10 inches deep at the walk line. So a lot of times these, at first glance, it might look okay, but it's not. Make sure you look at these winders. You got to have minimum 6 and minimum 10 inches at 12 inches in from the small corner. Another improper handrail. This one is not graspable. This one, 2x6, once again, not graspable. And then guards, not complying with current standards. I recommend upgrade for increased safety. And we see a lot of them here in California, where most of my inspections are, because we had the rules change from 36 to 42 inches height a long time ago. So a lot of us are recommending for optimal safety, consider upgrading the height of your guardrail. So probably most people don't do it, but we do recommend it. And then spacing of the vertical members. You can see here, now this one is more of a ladder rail. And this, just frankly, that was a code violation back, I think, in the first IRC in 2000. This was a code violation, what they call a ladder rail, but then it got removed from the code. But the spacing is a problem here. Should be no more than 4 inches. Here's another one. You can see we've got 5-inch spacing. So very common defect. Here's the height. Now this wouldn't have complied even with the old rules. 31-inch high. Here's another one, 31-inch high guardrail. It came up to like mid-calf. So that's quite low. And everybody here on this call is top heavy. And if you, including me, and if you lean over this too far, you're going down. So 31 inches is definitely not high enough for a guard. So I recommend an upgrade. And this one here on the left, we had spacing of maybe 6 inches between the balusters. Now this one on the left, this is a odd photograph. Right here, you can see that this is a drop down into the stairway. So can you imagine, coming out in the dark and you're trying to get downstairs to the bathroom and you fall over this. So there should be a guard installed here where my cursor is, because I know the drop isn't 30 inches or more than 30 inches, but somebody's going to fall. That's definitely a hazard. And then over here, this one, look at the this is the bottom rail of the hand guard rail, the combo hand and guard. And you can see here, that was like a foot, the distance here. Now that should be maximum 6 inch at that triangular location here. So that was a significant difference from what it should be. And you could, gosh, a 100-pound dog could fall through there. That's a huge hole. So that's what I got for us tonight, and I'd love to open it up for questions. And hopefully this helps clarify some things. And let's see what we got. Go ahead and somebody I think has been taking the questions. It looks like we got about 40, so I'm happy to go through them.
All right, Mike, I switched screens and I lost all the questions. So if anybody had a question out there or remembers a good one, feel free to chime in and ask Mike a question.
Here, I can look at them.
Yeah, check them out. Check them out. See if you find some good ones. In the meantime, when the text message comes out, the sign out token is going to be down. Step down, right? DOWN. Forgive the text message stuff. Sometimes that system gets a little bogged down. But if you have any problems tonight, we're going to open up the help desk and you guys can head over and talk to Amanda and she'll get everything squared away.
Yeah, I can see a couple of questions we can answer.
Yeah, man, go ahead.
I think, what time are we supposed to end? Like in 10 minutes?
Yeah, approximately. Yeah.
Okay, that's what I thought. So I wanted to leave a little bit for questions. So we've got, yeah, I see one here. We've got in New York, if you say 2x4 handrail is an issue, there could be fireworks. That's funny. So, certainly some localities will have their own interpretation, and that's always the case, regardless of where you inspect. The local jurisdiction, the local authority having jurisdiction, basically the inspector, they have the authority to interpret the code the way that they feel is appropriate. So absolutely, you're going to see differences. I'm just telling you what the code says. So, other people are going to have different opinions and they'll have exceptions. They'll just allow what they feel is right. Then we have, oh yeah, I like, take a photo of the duck. Your lawyer will thank you, about the basement stairs where they have the picture of the duck going down the stairs. Let's see. Oh yeah, good point here. I don't say code either. We have Kenny was talking about installation instructions. Now, a lot of times there's not installation instructions with building a stairway. So, but I don't say code either. Code's a 4-letter word for home inspectors. So I'm not suggesting that we say code. What I say is minimum standards. So that's what I like to use, is the phrase minimum standards. Sometimes I have, modern standards, something like that is what I'll use. I do not say code because I don't want people thinking that I'm doing a code inspection. Okay. Yeah, long nosing could catch and fail under a person. Yeah, absolutely. Long nosings more than 1.25 inches are wrong. And then don't say code. Yes, absolutely. I see a lot of here, don't say code. Yes, please don't. I'm not suggesting that. Safety should not be grandfathered in, always put to meet today's state. Yeah, I mean, that's what I was saying before, is that I always comment on these things and I recommend upgrading for optimal safety. Because remember, that's part of what we're required to look at. The ASHI standards of practice require us to report something that's unsafe. And the standards for building stairs and guardrails and handrails and all that kind of stuff have changed over the years because people get hurt. That's why they change. That's why in the NEC, we've had this recent change now where receptacles underneath the countertop of peninsulas and islands are no longer going to be allowed, because a lot of kids are getting hurt because of yanking on the cords plugged into those. So that's an interesting change. Let's see here. Okay, people signing in. All right, how do you report a winder deficiency on established property? Well, I just state the way it's supposed to be. for modern standard and recommend upgrade for optimal safety. That's pretty much what I do. You know, it could be unsafe. And a lot of times the only way to fix it is to rebuild the stairway. And, you know, I don't care. I told you what's wrong with it, and most people aren't going to fix it. And that's okay. The main thing, the primary thing is that I reported anything that was unsafe in my report. Yeah, and then New York Metro, we're trained to never say code. Yes, I've seen that several times here in the chat. I'm not saying to say code. Please don't. Okay, hopefully that's clear now. Is don't say code in your report. Now, it's our guideline, especially for stairways. What else are you going to use? There is nothing else. So our guideline for stairways is the code book. We don't want to say code in our reports because people then may think that we're doing a code compliance inspection, and we're not. And in many states, it's against the law for a home inspector to say something about a code. Okay. I think
Couple came in, Mike. Since 5 inches is only recommendation for the cut stringer,
yeah.
what dimension do you consider an issue or a defect?
You know, if it's like less than 4 inches, I'm reporting it. So that's what I use. And then the next one, inspection day, builder told me refrigerators are going back on GFI. Well, every receptacle in a kitchen requires GFI now, regardless of where it is. So hopefully that answers your question. So it's just every receptacle in a kitchen. The sink and the countertop stuff is the countertop thing is gone. It just says every receptacle. But there might be local jurisdictions are probably going to allow an exception with a simplex receptacle for a dedicated appliance, but that's going to be up to local jurisdiction. Okay, builder, I reported proper landing size. Puts a step diagonally. Okay, it's the inside corner. Actually, any part of a tread that's less than 6 inches would be wrong. How's that? I see Kenny was asking about that. Should be no part less than 6 inches. And then why do switch plugs sometimes show ghost power when the switch is off? Are you talking about current on the neutral? Maybe you're going to show some current on the neutral, probably. Maybe that's what it is. I don't know what we mean by ghost power. It might just be neutral current if there's something else that's plugged into the circuit somewhere. It could be just current on the neutral that you're picking up with your meter. Your tester will show light on the tester. It could just be neutral current. You know, if you're using a little circuit tester that's plugged in, that has a lot of limitations. So actually, it could be a little bit of current flowing on the grounding conductor too. So you'd have to have a real meter and plug it in and see what you're getting for voltage and where. So I can't tell you if it's just a light on the tester. It would take a more sophisticated tool to test that.
I think she's talking about our sniffer, Mike. Like when the sniffer near a switched outlet.
Oh no,
sniffer goes off.
Yeah, you think so? It says my tester will show light on the test. Oh, okay. You're talking about one of those no contact.
I think so.
Yeah, could I don't know. I need a more sophisticated tool to determine. So unfortunately, the no contact tester has limitations. It's showing some voltage, but it could be something on the neutral. Who knows? So sorry, can't really tell you. Not enough information. I
think this class was on stairs anyway, right?
Yeah, it's okay. I'm always ready to take a question on anything. I don't care. Whatever. I'll talk about whatever you want. So. Anyway, hopefully it was enough. I know we only had, about an hour. We went through a lot of stuff pretty quick. It's a lot of numbers, but
that was great.
Again, a lot of it's, right here in CoCheck. If you need a refresher, you can just go out and look at it. But I think the key thing is to understand how important stairways are and that people fall. And I think we should be a little bit more diligent, especially because we have to report unsafe issues. Just be a little bit more diligent with stairways, and make sure that we're looking at every potential issue there, or as much as we can.
Hey, Mike, I have a tip for you. Okay, question is they put laminate on the stair treads and then they
Yeah,
put a nosing on there.
right,
And nosing is elevated over the stair tread.
right.
I write it up.
Yep, me too.
It needs to be flush. Is that correct?
I write it up all the time, and usually it's loose and it like moves around. I hate that where they put the laminate, that transition piece that goes over the nosing
Yep.
is a different. It's a different profile, and it becomes a trip hazard. To me, I think it's a trip hazard, so I write it up every time.
Yep. All right. I didn't know if there was something in the code for it because I couldn't find it, but I certainly wrote it
You know,
up.
it might just barely comply. I think if it's more than 3/8 out from any of the surface, it certainly is wrong. But I don't think it's more than 3/8. It's just a little bit different. It's a disturbing profile because it's different, and it moves. So if anything moves, that's bad.
It's enough for a lady's heel to get caught on and trip and fall.
I know. I hate it when I fall wearing those, those high heels.
That's how I found it.
I got to wear them to test it, right? Wouldn't that be funny?
No.
All right. Well, thanks a lot, Mike. We really appreciate it, man.
Yeah, thanks, guys.
Great
for
job
having me.
again. If you guys want to catch Mike again, he's coming back to Rockville for our fall seminar on
November 4th.
November 4th. Thank you, Mike. You saved me there.
I just
do
booked the
mark
flight. That's why I remember.
do mark your calendars for next month on the 6th, September 6th. We're going to have Brian Deska, who's a structural engineer, come and talk to us about engineering stuff.